Now the first thing to note here is that we have a negative x squared, which means that the graph of the function is going to be a sad face. Now we want to work out the x-intercepts. We're going to use exactly the same steps as in the last video. So step 1, the x-intercepts was always a curve on y equals 0. So 5x minus x squared equals 0. Now you'll notice that this is not a trinomial. It's very easy to factorise. This is in fact a common factor. Take out the common factor of x, make it 5 minus x equals 0. Then x equals 0. We set each of the factors equal to 0. And if I add an x to both sides here, I get 5 equals x, or x equals 5. Now if we write these as pairs of coordinates, so we know that the y value is 0. So our first pair then is 0, 0. And then we've got 5, 0 as well. Second thing to do is to work out the y-intercept. There's always a y-intercept and always just one y-intercept. And the y-intercept occurs when x equals 0. Now if we put x equals 0 in here, so y equals 5 times 0 minus 0 squared. Now 0 times anything is 0, we just have 0, 0. Don't be surprised that we have an x-intercept at 0, 0 and a y-intercept at 0, 0. You'll see how that fits together. The third thing to do is to get the axis of symmetry. And that is found by adding the two roots together. So one of the roots was at x equals 0 and the other root was at x equals 5. So we add them together, divide by 2, and that gives us 5 over 2. Now, that's a fraction. That's fine, we can use that. You could use the value 2.5 if you wished. Next thing to do is to work out the coordinates of the turning point. Now we already know that it's a sad face graph. So what we'll have is a maximum turning point, which is to say the graph goes up to this point and then turns down, so it doesn't get any higher than that. Now we have, here is the original function, 5x minus x squared. What we're going to do is to substitute this value here in for x. Now this is a bit of a problem because it's a fraction, so we need to be careful. 5 times 5 over 2 minus 5 over 2 squared. Now 5 times 5 over 2, if we multiply a fraction by a whole number, we multiply top. So 5 times 5 gives us 25. The bottom does not change. 5 squared is 25. And we square the 2, so 2 squared is 4. What I want is a common denominator so that I can simplify these two. What I'm going to do is to change the denominator of the first fraction. I'm going to change this 2 to a 4. I'm going to multiply by 2, so I must multiply the top by 2 as well. That gives me a 50. I now have a common denominator. 50 take away 25 is 25 over 4. So we've got a maximum turning point at x equals 5 over 2 and then 25 over 4. So here are axes. This is the sketch. This should be part 5 when we bring it all together. So we've got an x-intercept at the origin and a y-intercept at the origin. We've got an x-intercept at 5. Now what I'm going to do is to draw in the shape. We know it's a sad face. Remember, these graphs are not drawn to scale, but they are drawn accurately. The next thing I'm going to do is to put in dotted line representing the axis of symmetry. So this is at x equals 5 over 2. And this maximum turning point is 5 over 2, 25 over 4. Here is a second example of a negative x squared quadratic. So again, we've got a sad face. First thing to do, work out the x-intercepts. They always occur when y equals 0. So 24 plus 10x minus x squared equals 0. We can put x in here. You'll notice that I'm not turning this equation around. We can factorise it as it is. We're used to having the x squared term first, but that's when x squared is positive. Now, the factors of 24. Factors of 24. 24 and 1. 12 and 2. 8 and 3. And 6 and 4. We're looking for... And this is interesting. We're looking for a pair of factors that will multiply together to give 24. But will add or subtract to give us 10. There are in fact two pairs. We could use this pair here or this pair here. Now, we've got a bit of a problem. We want to get one of the signs has to be a negative. So I think we're going to have to use the 12 and the 2. We could have maybe plus 6 and plus 4, but there's no way we could get a negative x squared. So 12 and 2. We want now we want a positive 10x. So the 12 is formed where these two multiply, 12x and 2x. So it's going to be plus 12x. We'll put the plus here. And then minus 2x. So the next thing is to set the factors equal to 0. That gives me x equals 12. And this one gives me x equals minus 2. So if we write them as coordinates, 12, 0 and minus 2, 0. Next thing, the y-intercept, always a y-intercept. And always occurs when x equals 0. So let's go to this equation now. Some of you maybe be able to get the y-intercept very quickly. This term must be 0. This term must be 0. If x is 0, that leaves us with a 24. So y equals 24 10 times 0 minus 0 squared. That's just 24. The next thing to do is to get the equation of the axis of symmetry. So we add the two roots together. Now we've got a root at 12. We've got a root at 12, an x-intercept, and we also have a root at minus 2, so it's going to be plus minus 2. So that's 12 take away 2 is 10. 10 divided by 2 is 5. So x equals 5 is the equation of the axis of symmetry, and we use that to work out the coordinates of the turning point. Now the equation is 24 plus 10x minus x squared. So we're going to replace x with 5. That's 24 plus 50 minus 25. 24 take away 25 is minus 1. Minus 1 plus 50 is 49. Now some of these numbers are large. Now remember, we have to state whether it's a maximum or a minimum. It's going to be a maximum turning point at 549. So the last thing to do is to make a sketch of the function. We've got root 612 and minus 2. We know it's a sad face, so it'll look something like this. We have a y-intercept at 24. We have an axis of symmetry at x equals 5. And this is the point here, 5, 49.